morning, students. Welcome back to our YouTube channel schoolquiz.com. And my name is Danish Agarwal. As we have started with chapter number 4, that is structure of an atom. In our previous two videos, we have discussed about the introduction of chapter structure of an atom, and in our next video, we have discussed about Rutherford model of an atom. So if you haven't watched till our first previous two videos, before watching that video, I advise you to watch previous videos first. Then we will proceed to this video. Okay. So now we will discuss our third model of an atom. That is Bohr's model of an atom. Bohr's model of atom. In our previous video, we have discussed Rutherford model of an atom, and as we know, chapter number 4 is what? That is structure of atom. Structure of atom. So, what were the three conclusions of? First of all, we will discuss conclusions of Rutherford model of an atom. Rutherford's model of an atom. So as we have to discuss about its drawback, so first of all we will again discuss the conclusions of Rutherford model of an atom. First one is it says the electrons revolve around the nucleus. And second one is size of nucleus is very small as compared to size of an atom. And third one is there is a positively charged species which is nucleus. So these were the main three conclusions of Rutherford model of an atom. But there is one drawback, that this one is the drawback. This is the reason for the drawback of Rutherford model of an atom. Now we will discuss how it is the drawback, how it is the reason for the drawback of Rutherford model of an atom. Rutherford couldn't able to explain that term which was totally explained by Bohr model of an atom. So first of all, what is its drawback or what is the limitation? Its limitation is, as we say, it is the nucleus. And here electrons are present. Electrons are present and electrons will move continuously, which means they are accelerating. Accelerating means they will radiate energy. Radiate energy means they will lose energy. As we know, accelerating particles will radiate energy. So at after some time or at some time, they will fall into the nucleus. For example, like these are electrons. They are constantly moving. Like moving. Then one time arises when they fall into the nucleus. They will lose energy and will fall into the nucleus. If it falls into the nucleus, it means atom is unstable. Which is not correct. As we know, atoms are quite stable. So he didn't explain the stability of the atom. if you want to write in like one line that what is the drawback of Rutherford model of an atom, you can say that, you can write it like that: he didn't explain the stability of an atom. He didn't explain the stability of the atom. He couldn't talk about the stability of the atom. Yeah, if you want to elaborate, you will write properly like that: as we know, electrons are revolving around the nucleus according to his experiment, and as we know, electrons are accelerating, and as we know, accelerating particles will radiate energy, and after some time they will lose energy and fall into the nucleus. And if they fall into the nucleus, it means atom is unstable. It means atom is unstable. But as we know, atoms are quite stable, so he didn't, so we can say that he didn't talk about the stability of the atom. He didn't talk about the stability of the atom. Now 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 we will discuss Bohr's model of an atom. Now we will discuss Bohr's model of an atom, that how he removed the drawback of Rutherford model of an atom. Drawback of Rutherford model of an atom. So there are the two postulates, two postulates of Bohr's model of an atom. Two postulates of Bohr's model of an atom. First one is only only certain certain special orbits. What is orbit? Where electrons revolve. What is orbit? Where electrons revolve. So first postulate is only certain special orbits. Only certain special orbits known as discrete orbits. Known as discrete orbits. It's of electrons, or known as discrete orbits of electrons are are allowed are allowed inside the atom. Are allowed inside the atom. For example, if we say it is our nucleus, so it is like n equal to 1 and like n equal to 2. This one. Electron can't revolve here. Electron can't revolve here. Electron can't revolve because there are certain special discrete orbits where electrons can revolve. Like if we walk in our market, we try to walk on footpath. We try to walk on the footpath or on the sides, or on the sides of the road, not in the center of the road. Not in the center of the road. If we want to walk, we will walk on the side of the road or on the footpath, not in the center. As like same in case of that atom, that there are certain discrete orbits where electrons will revolve, and they constantly revolve and do not radiate energy. For example, like I have already given that if we want to walk on the road, we will walk on the sides or on the footpath, not in the center, not in the center of the road. And same as in case of atom or electrons will revolve only in certain discrete orbits. And if and in the at discrete orbits, they will not radiate energy, and they constantly revolve and don't fall in the nucleus. So first main postulate is only certain special orbits known as discrete orbits of electrons are allowed inside the atom. Okay. Second point is while revolving, same thing which I have already told, that revolving in while revolving in certain certain discrete orbits, they they will not radiate energy. They will not radiate energy. Okay. So I hope this is clear to you. Now we will draw one diagram of this. Suppose this is our nucleus. And suppose it is like n equal to 1, it is like n equal to 2, it is like n equal to 3, and n equal to 4. It is like KLMN. It is like KLMN. N equal to 1 equal to K shell, n equal to 2 will be L shell, 3 is M shell, and 4 is N shell. And 4 is N shell. This is our KLMN. KLMN. So this is all about the drawback of Rutherford model of an atom. What was the drawback? He compared his model with the solar system, like that, like planets revolve, electrons will revolve around the nucleus. But it was drawback, as we know, when a particle will remove, it accelerate, and the accelerating particle will radiate energy. It means that the electrons will fall into the nucleus, which makes atom unstable. So this was the drawback of Rutherford model of an atom, but which was removed by Bohr's model of an atom. He stated that electrons will revolve in certain discrete orbits where they do not lose energy, and he regarded as n equal to 1 as K shell, n equal to 2 as L shell, n equal to 3 M shell, and n equal to 4 N shell. So this is all about our three models: Thomson model of an atom, Rutherford model of an atom, and Bohr's model of an atom, which all the three are very, very important, in which Rutherford model is the most important. Rutherford model is the most important. Now in our next video, we will discuss neutrons, how electrons are distributed in different orbits, like the structure. Like in sodium there are three shells, in which 281, like in potassium 2881. So we will discuss in our next video about that. So I hope this topic is clear to all of you. So thank you very much for watching our video. So share it with your friends, and thank you.